before we get started, also, I would like to thank our sponsors, Postman, specifically Kin Lane, the chief evangelist of Postman, for running our giving a talk at our data boot camp on Thursday and helping us create a bunch of Postman collections so that we could use Postman to help discover and explore NASA APIs and data sets. We also like to thank Flatiron School and Full Stack Academy for sponsoring and attending the event. We have a few teams here who've participated. We'd also like to thank the Internet Society for live streaming our event ever since 2012. I'd love to have you back, Jolie. And we'd love to also, obviously, the Explorers Club for hosting us here. This is one of my favorite venues I think we've hosted at the Space Apps Challenge. It's so great. Their mission aligns with ours so well. There's a lot of space people here. We got folks wearing NASA t-shirts. And we'd also like to thank the Bushwick Generator for hosting us overnight. We'd love to be back in Brooklyn, and we're going to be hosting more Brooklyn events in the future, so keep an eye out for that. And I think that's it. Hopefully I didn't leave anybody out. Also, obviously, thank our judges, Annalise and Stuart, who will introduce themselves right now, please.
Hi there. Thank you so much for inviting me down to judge this. I'm really excited to see what you guys have all been working on over the weekend. My name's Stuart. I work as a data scientist and developer for the Data Clinic at Two Sigma, which is a pro bono organization that helps nonprofits and academics and NGOs with their data science and development problems. But before that, a long time ago, I was actually an astrophysicist. I studied how galaxies form, and I worked at the Adler Planetarium for a while. It's through in Chicago, which is how I first came in contact with Space Apps. We organized the Space Apps Challenge there for a couple of years running, about 4 or 5 years ago. And it was really fun, and it was amazing to have lots of people come over and spend the night in the planetarium and just get to hack on things that they've never hacked on before. Moved through to New York about 4 years ago, and we helped actually run the Space Apps Challenge down in Bushwick about 3 years ago now. Jeez, yeah, that's like, time goes fast. And so I'm very well acquainted with the project, and I'm really, really excited to see what you guys have all come up with.
Hi, everyone. It's so exciting to be here. Thanks to Joe and Kate and all the amazing team, Jolie, for putting this together. I hope everyone has had a great experience and are excited as we are to see what the demos look like. My name's Annalise Valares. I'm the CEO and Chief Innovation Officer of Women's Sphere. It's a global platform and a foundation that is focused on empowering women and creating gender balance in society across all leadership ranks. We have a lot of focus on innovation and getting a lot more women and getting gender balance in technology as well. And I was a judge in last year's Space Apps New York and also sponsored Space Apps in the Philippines, which is where I'm originally from. My background's a little diverse. I was in investment banking at Goldman Sachs. I worked in Microsoft, and and then I started my own company and started a foundation. So I'm also a NASA data naut. So I'm one of the data nauts that NASA has, explorers of data. So cool. Thanks and welcome.
Thank you, judges. So I mentioned how this is going to go. Judges will, after the demos, will go off and deliberate, and they'll come back with 2 local winners. Those local winners will move on to global judging. They will be required to create a 30-second video this week and submit it next weekend. There'll be hundreds of videos being sent to NASA, and they'll comb through all of them and come up with some finalists, I think, end of year. Usually we hear around January when the finalists are announced. So go to Space Apps NYC, subscribe to our newsletter, and we'll keep everybody posted about what's going on with that. So with that, I think we're going to get started with our first team. Team name is Tech Explorers. Could Tech Explorers please come up? Followed by Unicode Unicorns. There we go. Okay, so there you go.
Yeah. Okay. Good afternoon, everyone. We're the tech lead. No, sorry. Not the tech lead. We're the Tech Explorers. Oh, can you hear me? Okay. Hi, we're the Tech Explorers. The 4 of us, Naif, David, Andrea, and I are from Full Stack Academy. We're lucky to have Vishnu to join us here at Hackathon. Our project is a web application that provides solar data for everyone, helping to accomplish the UN's SDGs initiative.
So the SDGs are the Sustainable Development Goals. There are 17 global goals set by the United Nations in 2015 to be accomplished by 2030. Our project is focused on 3 of those goals: climate action, energy availability, and sustainable communities. Goal 13, climate action, is to limit global warming and the net human-caused emissions of CO2, and to avoid the most detrimental effects of global warming. We need to move to renewable energies, and that's typically the only way that we can accomplish this goal that's been set out for us. Also, goal 7 is to increase the access to affordable and reliable energy. And in order to do this, in the developing world, access to affordable and reliable energy is extremely limited, and renewable energy, especially solar, is one of the ways to accomplish this goal, especially while focusing on underserved areas such as least developed countries and small islands. And finally, there is goal 11, which is to increase access to sustainable cities and communities that really ensure access to safe, affordable, and clean living environments. And renewable energy is also a major part of this goal.
Awesome. So our solution is a web and mobile application that has an interactive map, which basically allows people to find their location and get data about the costs that they can save with solar energy. And we're able to use the NASA Whirlwind API to get not only solar availability in big cities, but also in those landlocked areas and those remote islands and developing areas that we normally wouldn't be able to get.
And so the application basically does that. It checks for solar availability. So if you're a developer looking to look into an area to see if you can build solar there, it's useful, but also it's useful for checking if in a given area how much you might save with solar, which is extremely important for getting to net zero emissions by 2050. There's millions of people out there who could benefit from that kind of thing. And so right now we have an algorithm that does the cost savings. We're planning to expand it to sort of cover more things. So we definitely like help from people in finance or math or anything.
So our next step is to focus on the 17th goal, which is partnership for the goal. For that, we make these applications open source. So we welcome collaboration, partnership, and sponsorship, anything, and we can get more data and make we will get more data and make whatever we provide to users more accurate. That's it.
This is really cool and obviously a very important problem to be solving right now. Can you speak a little bit more about what data the API sent you and what parts of the calculations you were doing in the app, like how you were calculating the costs?
So we're using, as we mentioned, we're using the NASA data in order to get a global view, and then we're also using data from NREL, which is the National Renewable Energy Labs. They have quite a bit of solar resources data, and so we're taking the longitude and latitude that is provided to us when the user clicks on the app, and we're feeding that in as a JSON object into our system in order to get the data from NREL. And what we're then provided is basically a list of solar radiation. They also do a few calculations on the back end that give AC and DC. We do allow the user to specify the size of the system that they're interested in, which allows us to then perform additional calculations. One of the things we're looking into doing is to also integrate further into NREL system, because they do provide a very a good model for doing additional financial calculations, and that's a future step.
Oh, another question. To what stage have you arrived at? Like, do you have a prototype? Do you have a web app? Do you have a mobile app?
Sorry. There's a link. Yeah, sorry. So there's a link right there. So energynow.onrender.com. You can play around with it. It's kind of a mock. So you can click and sort of get the data you want.
It's not ready for live demo at this point, so
Yeah.
we're waiting.
All right, I forgot to tell everybody who the next team was. So, oh, I did. Unicode Unicorns. Up. Next up is we did that. Thorondor. I don't know how to pronounce this. Thorondor. Got it.
Thorondor.
Thorondor. Okay. Cool. There we go. You guys are here. I think it's this button, right? No, not that button.
Please stand still when you're presenting because we have to follow you with the camera.
Okay.
Is it this one? All right, you guys figure this out. I don't know.
Thanks, Joe. Yeah, it is that button. Okay. Oh, but we have to go back now. Hold on. There we go. All right, we are the Unicode Unicorns. Our project is called For Your Ice Only. And we are Caitlin Hertel, Kelby Stockstill, Emily Darrow, and Alex London, who also managed our socials. Also, that's me making my code work. I was excited. We chose the NASA challenge, which was called Chasers of the Lost Data. And so basically, our data that we were chasing is sea ice melt and sea ice content for the summer months when the satellites don't accurately capture the things that we need to know about sea ice. There's more water on top of the sea ice, which are called melt ponds, which is often mistaken for open water. So our calculations in the summer in terms of climate change are inaccurate. So this is the data that we sought to find.
So like Katie said, because of these surface melt ponds, the NSIDC, the National Snow and Ice Data Center, publishes only ice extent in their ice concentrations, not ice area. And the difference between those two things I won't get into right now, but ice area is more specific in its measurements. And so if we really want to understand what the impact of climate change is in the Arctic, we need to have a better measurement that's more exact of what that ice concentration is and how much ice we're seeing throughout the year in the Arctic Ocean. An article by a scientist at NASA JPL advocates for the use of literal image-derived products, looking at high-resolution images of the Arctic and translating those into this is surface melt, this is open ice, this is snow, this is open water, and using that to help improve the calculations that are being performed to understand what ice concentration is in the Arctic Ocean.
And so our data sources were Meteomatics, who is our sponsor for our team. All of our weather API information, which you'll see on the screen in a moment, came from Meteomatics. Easily accessible, very, very accurate data that goes all the way back to 1979 in some cases. Also, the US Geological Society, where we got our satellite imagery, and the NSIDC, where we got the processing for those images. And here you go.
And so this is just all of our data points plotted up against each other and all of our different inputs that we tried as far as predicting what surface melt looks like in comparison to the open water. When it comes to our data analysis, given the time constraints that we had, most of what we were looking at was linear regressions. While what we initially started with was quite abysmal, in some cases below 0.1. As far as looking at the immediate weather data, temperature, wind, humidity, and radiation, our adjusted R-squared value was 0.81. And we're trying to hit as close to 1 as possible to be as accurate as possible with our predictions. Going from there, instead of just looking at the immediate weather data, we began to create aggregates over that data. What we ended up with as far as our most improved thus far, our adjusted R-squared value is 0.89. That's based off of including the 7-day temperature averages and the 30-day humidity averages. Just a look at what those pair plots look like. We don't have a lot of images when it comes to high-resolution Arctic sea ice. From what we have, this is what our pair plots look like. This should look like a straight line if we're perfectly predicting it.
So, in terms of the rest, we did additional conditioning of the data and, sorry, having a moment, checking additional aggregates. So one of the things that we did was
We perform those aggregates.
yes, we performed those aggregates. We put the data together and we summed it and we meaned it, and using that together, we were able to get more accurate predictions and get closer to that 1.0. In terms of additional samples, one of the things that we worked on was using image data from bin files that we were able to get from the NSIDC, right? Yes, and using those, we were able to get existing sea ice concentration at specific latitude, longitude coordinates to check some of our predictions and things like that.
So one of the things Emily just mentioned is that we put in coordinates. This project is not just for the Arctic Sea or Arctic Ocean. You can put these coordinates in anywhere, and we can run sea ice concentration anywhere in the ocean, in the world. That's why this project is so relevant. We can apply it to wherever we want, learn more about climate change in that location and how it's progressing or how it's not. And right now, as it stands, we don't know what's going on in the summer. So that was our main thing. The automation of processing of satellite images definitely helped this project. I'll let you talk more, we're over time.
One of the things that we'd like to do, because we have such a limited data set when it comes to those high-resolution photos of the Arctic Sea, is help with the processing of those satellite images. The part of the United States Geological Survey, the Global Fiducials Library, has a set of these images, and we'd like to try and improve the methodology for processing those images, given that it is currently highly labor-intensive going through all of them, trying to mask any kind of cloud or any kind of other interference. So we'd like to try and apply additional machine learning methods to that to help improve and hopefully increase the data set that we're working with. Yeah.
And that's it.
So the model you guys built was trying to predict the percentage of ice melt on each one of the images, or was it on like a per pixel basis?
So we're trying to, given each of the images, it gives us a percentage of ice, water on top of ice, and open water. And so we were trying to predict what that open water percentage was. So in context of what's in the NSIDC, they have ice concentration measurements, which is just the ice that's shown. On the other side of that, 1 minus those values is whatever water is seen. So that includes both surface melt and open water. And so we're trying to predict the open water component of those.
Okay.
And the other thing that I was going to say is that actually, you know what? I forgot. So yeah, I'm not sorry.
Yeah. So, do you know what the downside, the ultimate value? What's the ultimate value of fixing these satellites so that you can operate them over summer? What's the downside to not having them running right now? Like, what's the detriment to science, basically?
Well, right now, we have a ton of scientists working on climate change, and we know a lot about where our future is headed, and it's not a happy place. And right now, it's very important for us to be able, all year long, to be able to say, this is how much the ice caps are melting, this is how much the ocean is actually growing, and see at what rate it's repeating. So every year, if we can predict this, then it has endless boundaries. But what I was going to say before was, in addition to what Kelby said, was we currently have a Terra satellite that looks down and creates 3D models. And when you look at those 3D models, it makes the Arctic Ocean look like the Antarctic Ocean, as if there was a landmass because there's so much ice. What we know is that that's not all ice. It's open water mixed with ice, icebergs, there's little rivers that go through. And right now we're calculating all of that as sea ice. And that means that there's more ice, that we think there's more ice than there is. And there's not. There's no ice in between. And so that actually means that our calculations are off and that our situation is actually much bleaker than we think. And just because of how wrong in the summer the calculations can end up being. So that's what we work to correct. Thanks. Yeah.
All right, right up now is Thoron, and then up next is De-plastified.
I'm not plugging in. I'm just using this to read.
Yeah, you guys just have the video, right?
We weren't going to do the video because it's got what we're saying here, and it's not high quality.
Yeah. So just know, everybody, I'm giving everybody a little extra time because we don't have that many teams, so it's fine. But keep an eye on me. I will let you know when you're close to going over, just so we can keep it on pace. And there is a clicker if you guys want to use this. I got it this weekend. It's pretty cool. So.
All right. So we are Team Thoron. I'm John.
I'm Mansa.
I'm Emma.
Thorondor. Thoron is an app for piloting a drone wherever you can imagine. In the near future, there will be rotorcraft on Mars and then Titan. An intuitive app for piloting an unmanned aerial system, such as a NASA space drone, is essential. Thoron allows a drone pilot to take over control of the automated drone in the event something goes wrong during mid-flight and the autonomous controls do not work correctly. Mars rovers move slowly in part because of concerns about the rover hurtling towards danger before a flight controller could command it to hit the brakes, which is a result of the signal delay. A similar idea would be implemented in Thoron. The team is still analyzing in simulations what the best method of implementation of this. However, one idea is that Thoron could use a gyroscope, among other sensors in the device, in this case a phone, to allow for operation of the control wheel, aka a yoke. However, Thoron would limit each movement of the device to 1 unit of movement of the rotorcraft, say 30 centimeters or 1 foot, and report back before allowing the pilot's movements of the handheld device to contribute to movement of the rotorcraft. Another idea is that this would be accomplished physically through a large platform. Whatever is found to be the most effective operational method will be chosen in the simulations. So if Matza could talk a little bit about the what we were actually able to accomplish this weekend.
Okay. So, we wanted to just basically start by using the accelerometer and the gyroscope to get the movement on the X, Y, and Z axis and get the roll, pitch, and yaw movements. So the first part we did was we're able to get the Android app trying to, just read the accelerometer and the gyroscope. So that part is done. Since we don't have a drone, which is going to be able to, we can translate the movement to the drone, we just tried to work on simulating the drone using a Parrot Sphinx, if I remember right, but ran into a situation where I installed a higher version of Ubuntu, but it needed a lower version, so I'm trying to work on that part. So ultimately, it's like, imagine your phone like this, the Z-axis, the Y-axis, and the X-axis, and you're able to play with it as a joystick, which would translate the movement to the movement of the drone, and of course add errors when you hold it so that you don't try to move it too much, assuming people move a little bit like this, shouldn't be able to translate that. So that's our basic idea. We don't have much working because we have a lot of technical difficulties, and the problem is very interesting.
Short. She got something done. It's on GitHub.
But you really need, if we had more time. In that case, you could actually get a simulation of a drone app and at least try to move it through our environment. So that's about it.
Do we have time? Just to wrap up, I think that, so the problem right now, I don't know how many of you fly drones, but the problem right now, so I don't have to stand on my tippy toes. The problem right now is that navigating a drone is really weird. You have think about where exactly the rotors should go. So So if you wanted to go left, you have to go, oh, my right finger should go there and my left finger should go here. It just makes zero sense, intuitive sense. So that's a problem that we're trying to solve. And I also think, yeah, we don't have a drone, so we can't figure out how it works on an actual drone. But I also think that making it work, hopefully one day, making it work on a simulation is a strength of our project, because we can then simulate different environments such as Titan and Mars, or, you know, the universe is very big, so anything else.
All right. Thank you.
So you mentioned if you had more time, you could, you know, get something working. What specifically were the big blockers, and what would you need, and like how much more time? Can you just elaborate? Given more time, what would you do?
So the first part is we don't have an actual drone. So they gave a link to simulate the drone using Parrot Sphinx, and it took a while to figure out how to get the drone actually have a model of the drone simulation. And then the next part is you would want to have an environment in which you could actually drive the drone in, because the problem talked about avoiding not crashing into stuff. So Gazebo was one of the simulators where you could have the physical environment working in. So we actually have another teammate. I'm so sorry he didn't turn up, but he made it working, but I wish he was here to show that.
He was still sleeping. He was up pretty late.
I'm not sure, but yeah, sadly he's not here. He cracked that problem. I was working on getting the Parrot Sphinx up. Needed Ubuntu. I was working on it. Ultimately, somebody online said it doesn't work with Ubuntu 18.0 version. You got to go to the 16.0 version. And I was like, oh God, it's 11 o'clock. Back up. So yeah, so that's it. I guess it's just a little bit of time. Maybe I think if I have a day or so, I can get the Sphinx working, and then we can at least have the drone moving through the environment. And then it's all about then bringing the understanding how the accelerometer and the gyroscope would translate into actual motions, which can be, you can see the drone moving. So, yep.
So there's lots of different environments you guys were mentioning that you might think about flying these drones in, and they have like very different characteristics. So I'm curious about whether or not the simulation software you were using allowed you to kind of like simulate Mars, which has got a lot, like, you know, less dense atmosphere, or somewhere like Titan with very thick atmosphere, etc.
Our third teammate, fourth teammate, actually.
That was mainly his thing, but it did look like from what we were seeing that they.
There are ways to, he did mention to us, one of the last things he mentioned to us was that there is a way to control the density of the atmosphere and various things like that. I'm not sure about gravity, but if that is not possible in the existing simulation, then that's definitely a crucial component of our plans for the future.
So, but that would also mean that you need to add other sensors that help you with your stuff based on the environment. Like maybe you need to have a proximity sensor, something of that sort. So,
Quick plug for drone technology. NASA is doing a lot of missions where they're sending drones to other planets to fly around, and programs called Dragonfly. There's going to be a lot of this happening in the future. So if you're interested in this kind of thing, there's a lot of opportunity for it. Cool. Thanks, guys.
Thank you.
Reset. There. Where am I? All right, that was Thoron door. Okay, up now is De-plastify. Next is Heavenly Bodies. There you go.
Hello, everybody. We are Team De-plastify. My name is Dan.
I'm Adrian.
I'm Chloe.
And we are here to show you our very simple app that is supposed to get people together to get excited about picking up trash.
So we picked the challenge to handle the plastic problem that attacks our ocean and land. And obviously NASA has started tackling this problem. This is a map of garbage patch a visualization experiment done using drifters, which are basically buoys with sensors that send signal to NASA satellites. And those white dots, each one of them is a buoy. And they measured movements. But as some of you know, that a lot of those plastic, so they use buoys to emulate plastic movement, current movement, and things floating in the water. And they gather in 5 garbage patch around the world. So when we look at this data, so first, in order to solve a problem, you want to understand the problem. Where are the garbages? And we sort of know they are in the ocean and where they are. But looking at this map, you notice we start with, thousands of buoys, drifters, and when we finish this visualization experiment, only small portions of those drifters can be seen in the ocean. So question is, where are the other drifters? And the other drifters drifted to the shore, and they have record of where they landed. So we thought we can use, so the buoys are basically plastic balls. So we thought maybe we can use those buoys. The assumption is those buoys are plastics, and we can use where the buoys land to know where the plastics in the ocean goes. And once they are in the ocean, we have all seen the plastics on the beach and everywhere in, scattered along the coastline. And those are the things we can see. Those are the things we can pick up. So we designed this app to connect the data, garbage data, with the effort everyday people can put in, connected with volunteer effort to pick up this trash. This is some details of the data we want to use. So the drifters, when they put down, when they get detached from, let's see this. This? Right. That's the drifter. This is the drifter. The top is a buoy. It's called surface float. And it has an antenna that sends signal to the satellites. And this is the drogue that has all sorts of sensors to sense the temperature, the current, speed, and whatever. But when this broke, this thing, just a plastic ball, just float with the current everywhere. And this data, so this is first landed. This is the end date, latitude, longitude. Then there are some other data. This thing is cool. This is called death code. When it's 0, it's still alive, meaning float in the ocean. When it's landed, it's run aground. So there are other categories. We filtered for death code 1, which are agrounded drifters. We can use those to assimilate regular plastic trash floating to the ocean. And this is, so history data, there are so many drifters released from boats and different parts of the Earth. This is all over the globe. And this, we have 5,000 data points with death code 1. So the idea is to use those landing point as the starting point, as the hotspots for plastic gathering. And this is the app we have developed to connect those data to people's effort to pick up those trash.
Thank you. So it's pretty simple. We have 3 main parts. We have your sites, your events, and your pickup. A site is a physical location where people want to go to pick stuff up, and that can either be created by a user or we use the data where all the trash is likely to be from the buoys. Then you have your events, which is tied to a site, and that's good for like group pickup. So say you want like a company retreat and picking up some trash, or something like that, or just get together with a bunch of people, have a party. And then your individual pickups is just a way for the user to record their impact throughout their process. And just to go through, you have your landing page here, you enter your location, and it'll give you the sites that are closest to you in a little map that would eventually work. Then you go through, you have your little cards here, you can view a site, which gives you all the information about the site, the trash level, density, where it is, and all of the locations or the events associated with the site. And you can also create a site.
So then this is where you can record your cleanup activities. So you can enter a new pickup, record when you did it, the site you were at, give a brief description, then estimating just by weight how much plastic waste or other waste you picked up. You could also upload a photo showing before and after you clean the site to track that progress. And then you'll just have a history of your personal data of when you cleaned up and where.
Why do we need an app to pick up trash? Why do we need an app to monitor our run? Why is there a map for keeping track of our biking routes? Because it's fun. Because it's a sport. Here we are pushing out the idea of eco sports. What is eco sports? Eco sports is a morning run on the beach and finish up with picking up the trash and bring it home. Eco sport is a quiet stroll in the forest and pick up the trash as you see it and Instagram it. And then eco sport is a dedicated team building event hosted by a company going to an identified hotspot and clean up the garbage. So with De-plastified, you record your pickup and keep a log of how much you have picked up. And you could earn a badge after you reach a certain milestone, like your YouTube plaque. And then, our app has the picture before and picture after, and you can record the success story of the beach next to you. And then, host a party, have fun, and do good. And, make it a trend. Everybody wants to do it. So then, big companies can do big things. Small people can do small things. It's fun, and you have fun, you do good. So there we have it, De-plastify. And we hope this app not only is a solution, but we start a movement for eco sports. That when we work on the wellness of our individual, we work on the wellness of our earth. So right there, our Explorer Club just saw the inception of the concept of eco sports.
I really like this. I like how you guys have thought through not just the data, but also the participation of people and how to get people excited about this. One thing I really like about your app is that you're also collecting data as well. So as people come and give you information about and like how much they've cleaned up on a beach, you have that information to do more with. Did you think through how that could then help enhance what you're doing, or how you would use that data to make the app even better?
Yeah. Did you see the part about register a site?
Yeah. So. Yeah, the idea is that you'll actually be able to register your own sites as well, because we wanted to start out with the database of where these drifters are landing to say where trash is likely to have accumulated on the coastline, but then you can create your own sites, and that data would hopefully be available to everyone then. So if there's a beach near you or a coastline near you where there is a lot of trash, you can mark that on the site, and then that's available to other users for also they can go clean it up too.
Just a quick question on where you are on the stage of this. Like, do you have a working prototype? Is it on the web? Is it like where are you?
You've pretty much seen it. These are just mock-ups. We kind of came up with the idea a little bit late, but I think we have a pretty good idea, right?
We do have a pretty good database.
We use Rails backend API, and we actually have mock data. The drifter data is in there, and we're working on putting that on the map and front end, then did the front end. We have the ones you have are live, and we need to add event, like to create an interface for people to enter event. So, yeah.
Yeah, so these are all focused on plastic that went aground somewhere. Has there been any thought about underwater, anything that's caught in like coral reefs or anything that stays stagnant? I don't know if that is a thing, but is there any way of applying this to cleaning up plastic that hasn't been run aground?
I mean, yeah, you could, if it's user-generated data. So say if you see that in the ocean, you can just pin the location in there, I guess, or plan an event to get a boat full of people to try to come clean it out.
That sounds like fun.
So
yeah. On a boat, right?
Go ahead. You want to?
Cool. I think
So, the patch, the garbage patch inside the ocean, there is a Netherlands company. They call it clean up. Yeah. So they actually devise a solution, which is basically to use a long, flexible, floaty band around those things and pull them together and send boat to pick them up after a while. And those are, like a big organized effort. But for under ocean, I think the understanding is not that as much.
Cool. All right. Space Apps NYC Eco. Let's do it. By the way, death code, I'm stealing that. That sounds so cool. All right, let's see. So that was De-plastified. Up now is Heavenly Bodies. Next is Data-ster. Heavenly Bodies? No Heavenly Bodies? All right, Data-ster. Data-ster is up. After Data-ster is Snaky Panthers. Sneaky? Snaky? Panthers. Panthers are up next. All right, you guys are here. Is this it, or is there something else?
Yeah, that's right. And the slides, the pitch deck. It's the one that is, the pitch deck.
To the left?
Yeah.
Very cool. Present right there.
Is it two window one?
I want to open the other window also.
Open it separately. You drag the tab up.
Not this one.
What's that one?
It's.
Oh, okay. Can you put it another tab?
Yeah,
that
so-
I can just scroll later. Like,
So you want to? Oh,
on
yeah.
full screen too. So
Yeah,
that I
there
can
you go.
just scroll.
Yeah, and try it. There you go.
Okay, good afternoon, everyone. Today, our team is going to present on the challenge from curious minds to helping hands. So to start things, we are called Data-ster. So it is a blend word from the word data and disaster. A little bit morbid, but yeah. So we believe that data is knowledge, and knowledge is power. So with data, we are able to bring about an impactful change to make the world a better place for everyone to live in. In this challenge, we focus on using satellite data to optimize landslide rescue efforts. So some background context for everyone. Did you know an average of 25 to 50 people are killed by landslides, and losses are estimated to be between 2 and 4 billion in the US every year? The global toll for landslides is the heaviest in developing countries, where people are the most vulnerable. Landslides can occur at any time and at anywhere, often leading to unexpected losses in terms of lives and infrastructure. So the tricky thing is that people who are usually trapped in the event of a landslide, they have to be rescued in the first 48 hours window in order for them to survive. So the race against time is a thing here. So imagine if your loved ones are the one that is being trapped during a landslide and help is still on the way. How would you feel? You would feel anxious and helpless. So this motivates us to come up with the platform called Data-ster. So, how can Data-ster help? Previously, rescue teams usually arrive too late to make a life-saving impact, and the local community have little to no capacity to help at all. So with Data-ster, our live tracking feature of landslides, weather, and incoming help messages aids in decision-making for deployment of manpower to help. This allows the vulnerable populations to be reached in no time. Now, I will hand off the time to my teammate who will present the demo.
Right, I'm going to do something tricky. I'm going to do a live demo actually. How do you switch? Oh no! Yeah, no worries, we got it all figured out. Yeah, okay, that was good. Right, so what we expect to see is actually for an emergency manager or like a relief worker at a command center to get an overview of how the situation is looking like, and what you're looking at is actually the area marked out in Nepal. Nepal is one of the areas with a lot of landslides every year. Right. And so we try to make it as intuitive and as easy as possible. The map is draggable and movable, like how you would use in Google Maps. And so at the bottom, you can see that we can toggle risk area, landslide area, weather, and also missing people. So people can actually report, you know, if someone is missing in landslides, you can see their data, right? And so now, so you might be wondering, like, what are these circles? These circles indicate the risk area where landslides are likely to occur, and when you click on them, right, so you'll be able to see a vulnerability score. So this score is generated from a model which will include social factors such as the literacy rate, the gender, as well as factors such as the population density to assess how dangerous an area is, the number of people that would likely be in higher danger because of a landslide, and then this will be color-coded to let you know which areas require help first. And then this score is to intuitively let you know where you should approach, where you should dispatch help first. On the left side, you can see we rank the areas and we have sorted out by vulnerability score as well. And so you're able to look at one glance where you should get the relief workers to first. And now on the bottom, you can see their updates. So these are messages. Yeah. So these are messages that will be sent in. We will get people to send in messages, and they can give you live updates of where help is needed so that you can make better decisions all in one go as well. Yeah, and that's about it. The landslide and weather data are actually live data from NASA that we got, and we integrated using the API. This is written in React.js, and yeah. It's okay. Right, okay, and so currently, with our app, we are able to allow rescue teams to know where to deploy manpower, and what is next. What we want is that we can allow rescue workers on the ground, after having the information and dispatching the workers on the ground will now receive a notification to know where exactly they should go to help people first, and who they should help first, because that's all the challenge is about reaching out to vulnerable populations. Right, so yeah, lastly, together with NASA, we hope to make the world a safer place to work, play, and live in. And yeah, thank you.
Any questions? For some reason, we don't know why the landslide and weather data is not showing. Yeah, but it's supposed to show. You were showing just now. Yeah.
This is primarily for first responders, people who are going to go and assist people who have been trapped in landslides?
So for now, because of the data that we have, that's available on, let's say, NASA, etc. So for now, this app is actually for people, for a rescue organization to make better decision on where to deploy people to. But in the future, we feel that this is not enough, definitely, because like what we mentioned, 48 hours is so crucial, and maybe sometimes rescue teams can even go in later than that time period, and people there who are experiencing the disaster are the people that can help to deliver the aid first. So that's something that we want to take a look in the future. Yeah.
So you guys have predictive analysis here saying, this area is more likely to have landslides. Is there any thought about, is that correct?
Yes.
Like the big area. So is there any thought about like warning people, hey, you just entered a high risk zone for a landslide or anything like that?
Yeah, that's something that we can definitely include, but it's not included yet. Yeah.
Cool.
Thank you.
Test. There we go. Okay, so that was Data-ster. Next up is it Snaky Panthers or Sneaky Panthers? Sneaky? Sneaky Panthers. There we go. I think I'm missing an E on here. Sneaky Panthers, and then last up is Fastidious. Or what's your name now? Orbital Janitor. That's it.
I'm Anaya, and I'm 9 years old, and the challenge I picked from NASA was finding a way to take microplastics from the water by using NASA's data to track the ocean currents so I can put my invention in the ocean currents around the garbage islands. My invention is cheap, low-tech, and is eco-friendly, and anyone everywhere can use it. My name is Anaya, and I'm 9 years old, but you can call me the Black Panther. Da-da-da. And I love coding, inventing, and the ocean, and I'm really excited to tell you about my design. Using NASA's data about the ocean currents, we can see how it affects the ocean. More specifically, the Great Pacific Garbage Patch between Hawaii and California. Microplastic is under 5 millimeters in size, and it's because water breaks down the plastic over years. And fish eat the microplastic, and that is stuff that we eat. I was sitting under the big blue whale in the Museum of Natural History, and it hit me. Not the whale, but the idea. Whales are natural filters with their baleen. They filter stuff every day. So I was thinking, what if my device filtered microplastic like a whale filters its food? My design is a square metal box, and the filters are made of coconut. There are 3 sections. The first 2 are filters, so it only collects microplastic and doesn't collect anything else. The third section is where the ROSs are, which is short for reactive oxygen species, and they are poisonous to the ocean by itself. But when they are with carbon nanotubes laced with nitrogen. They are safe for the environment. And it breaks down the microplastic in under 8 hours. And then it gets pushed out from the back, clean water. My invention does not cost a lot. It is easy to use, and anyone everywhere can use it. The ocean helps keep our the ocean keeps us alive and healthy. And I want to tell anyone that if you can believe it, you can achieve it. And anywhere, everywhere can know that they can make a difference in the world too.
Thank you so much. That was excellent, and there was obviously so much research that went into everything you did there. I love the fact that you got the idea of sitting under a massive whale. What would you call your devices to put them in the ocean? Do you have a name for them?
Yes, I called them the microplastic eliminator.
Nice.
And at what stage do you have a working prototype for this? Have you done tests and do you already have the device?
I have been making prototypes and with pipe cleaners, and they've been working out pretty well.
Nice. Yeah. Whoa.
All right. Pipe cleaners get you pretty far in this world, by the way. It's one thing I learned in school. All right. Oh, thank you. All right, last up, Orbital Janitor. That's all the teams, right? We got everybody? All the teams? Cool. There you go. There you go. Do you want to introduce this? This is going to be too high. There we go.
We're Orbital Janitor. I'm Sandy Barnabas.
And I'm Alex Barnabas.
Jonathan helped us out, but he wasn't able to come today.
Okay, so we are orbital janitors, and the problem. So what is the problem exactly? The problem is that there's too much scrap and crap in space. Over 50 million pieces of scrap from fallen or just crashed and failed tests on satellites and rockets have been collecting in the lower Earth orbit. And although most of them are like paint chips and smaller pieces, even a paint chip can dent a window since it's going around 10 kilometers per second. Why is cleaning up space important exactly? If a paint chip or larger piece of metal damages a satellite and takes it out, such as like the ISS, you will lose things like phone signal, television, radio, GPS. There's no way to track incoming meteorites with the satellites, no weather predictions, and launches in the future will be riskier as more scrap increases. Our goal is to raise awareness. The first step is most people don't know about the problem. The first step is to solving it is making sure people know about it. We want to help inspire people to come up with solutions because no one can solve it if no one knows about it. And now for the demonstration.
So we built a web app. There we go. And the whole the kind of conceit here is that you're launching a spacecraft and you're trying to clean up orbital scrap. So we pulled data from NORAD and Celeste Track. This is actually data from the Iridium satellite constellation. There was a fairly well publicized satellite crash in 2009 that caused debris to, satellite fragments. So you can launch a rocket, and it'll display the orbit of your rocket overlaid with various debris. We didn't quite get to the point where you actually can score, or multiplayer, but the idea is that as you change your orbital parameters and launch different rockets, you're cleaning up the scrap. So we have a collision detection, or I guess nearness detection. So if you go close enough to a piece of scrap, you'll pick it up, and your score will increase. And you can, if you are, I think you can see here, it uses standard orbital parameters to control your launch. So here, for example, we can change. You can see that if we launch another one. And obviously, this is just one data set. This is, like I said, the Iridium data set. We also have the other, where is the ship? We also have a few other data sets, but due to performance reasons, we can't show them all. There's too much scrap for this web browser to really render effectively. Our goals are to make it multiplayer, so you can have multiple people, and have a live leaderboard. I think one of the things, as you can see, there's a lot floating around, and I think people can't really visualize how much there is. People think of space as empty, but there's a lot of stuff floating through it. And we think one of the things this will do is encourage people to think about what is actually up there above their heads.
So this is a really big problem and only going to get worse as we put more and more things out in space. I really like the idea of making this a game to raise awareness, but the other thing you could do with it, I guess, is to use it to figure out how likely a ship is going to be to be hit by a meteorite in space or some debris in space, and that could also lead to awareness. Is that something you think you could build into this?
Yeah, actually, that's kind of where we started with the collision detection, and we thought it would be we want to incentivize good behavior, right? So we pivoted to treating this to instead of trying to get an orbit that doesn't intersect with debris, it's more, if you launched a cleanup satellite, where would you launch it to pick up the most debris? So it's the inverse of that problem. Yeah. But yeah, that's actually where we started from. Any other?
No, that's cool. Awesome.
All right,
Thanks, guys.
great, thanks.
All right, so that's all of our presentations for today. The judges are going to go somewhere over there, not in here. Do we have another team? Did we get everybody? We have another demo, yeah. Raise your hands if you have not demoed, because we may have missed some people. Yes, anybody? I can't see your hands, raise them up. There you go, higher, okay, I see. Okay, yeah, guys come up. What team is this? Was it this one? Yeah, this one. All right, cool. And what's your team name?
Fake Tiger.
Fake Tiger. There you go. Take this, and just remember to speak into the mic. Oh yeah, you don't need that. Yeah, there you go. It's a pointer. Yeah, you can point it.
Okay, hi everyone. Our team name is Fake Tiger. I'm Jashu, and this is Boya. So we choose a challenge to chase the loss of the lost data, because in the data analysis and machine learning field, the data quality matters a lot on the accuracy of the model we build. So the missing data can occur from lots of different reasons. Some may because of the sensors, they are not stable enough, and some might because of the people who enter the data. They have different kind of typing habit, and they might lose some informations. So in this challenge, we're trying to build a Python package to handling those kind of missing data. So we started to explore a little bit on the NASA data, which is meteorite landing data, but hopefully in the future we're gonna create a package that can be used to all kinds of research data or other public data, stuff like that. So what our package can do, So first, we're gonna like summarize the loss data ratio for each column, so we can know like which sort of data is missing in the whole data set. And then we're gonna impute by finding the columns with the same patterns. Like for example, in the data we explore, we find there's like 3 kinds of columns. They're called country name, and country code. But actually, they have the similar informations. We only need 1 columns. And in country name, there might be some missing data, but in country code, they have like all the data. So by comparing this, we could just like ignore the country name and just use the country code columns. And then we're gonna fill the gap data based on columns, which means for some data for some columns with some special characters, we can try to find the medium or mode of those kind of columns and try to fill them. And first, we're gonna fill the data based on the rows, which means we're gonna use the some future. We're gonna build some other machine learning models, try to predict these columns based on the information of other columns. And then we're gonna work on both the continuous and discrete data and try to create a CSV file with no missing data.
Okay. Hi. Okay. So we use the meteorite landings data set as an example. So in the CSV file, we find a column which we might be interested in. It is called, I don't know, the found column, like whether the meteorite is found or not. So for the other columns, it has like the meteorite class, the mass, the year where it falls, and the latitude and longitude. However, we can see actually for some of those columns, we have some of the data missing. And within the package we have made, actually, so the package is there on GitHub, and we use it to fill in the missing data and show the accuracy results on the found column. So we try to use all the other 5 or 6 features to predict if this meteorite can be found or not. So as you can see, we tried 3 different imputing strategies: a naive strategy, which just replaces all missing data with a 0, or we can use a mean and a median. Those 2 are also based on columns only. We also have ideas to fill in the gap data based on rows, but we haven't done the experiment results for that. And as you can see, we did get some gains by filling the missing data with the mean of the column. And we would expect by using some more information from the rows rather than the columns, we may have better results. That's it. Thanks.
No, I think we're good. Thanks. Thank you, guys.
All right, cool. So I think we got everybody now. So we're going to go off and chat, and we'll come back in a minute. So everybody, judges are back. We'd like to announce the winners now. First, we want to just say that there was a lot of consideration for a bunch of these projects. It was quick, but we were just racing through because we know you all want to get home. So we want to say that there's a lot of potential here. I heard Caitlin mention that we do want to work with you to develop these projects further, and we will be reaching out to you about that. But we do want to give, just as a baseline, we have 2 winners. But we also have an honorable mention. We want to give an honorable mention as a close runner-up to De-Plastify for their plastics game. So the 2 winners for this year's Space Apps NYC challenge are Data-ster and Unicode Unicorns. We don't have any trophies, but we do have certificates for participation that are sent to us by the global organizing team. You can pick those up on the table outside, and we have a little marker there if you want to write in your team name or your name or anything like that. So we just want to say thank you again for attending this year. We know it was a bit chaotic getting everybody in between both places, but we are looking forward to doing more events in 2020. Science, tech events. If you guys, I know you're all interested in space, so we'll be doing more of that. So stay tuned on Twitter and follow us on all social media. Subscribe to our newsletter and the Facebook page. Don't forget about the Facebook page. So keep an ear out for other stuff we're doing, and if not, we'll see you again next year. Thank you all for coming. Thank you, everybody.